Hi everyone, and welcome to the 12th episode of Dev Show. My name is Sherry List, and I'm your host today. And we have Rasmus Jack back. Welcome back, Rasmus. Did you have a nice vacation?
Thanks. Yeah, it was really nice to get some time off in the summer house, but still staying in Denmark. So in these times, not traveling that far. But good to be
Yeah,
back.
welcome back. We're happy to have you back again. So, as usual, we have an hour of awesome show for you. Where we have one speaker and one topic. And Rasmus is going to give you all the details. Before that, I'm going to remind you that you have a chance to ask your questions from the speaker by typing it in our chat, and also you can let us know that where you are watching us from. And one thing to remind you, actually not remind you, this is something new, that we are going to actually give a present to the best questions, that our speaker is going to choose the best question later on as well. And speaking of chatting, I wanted to also remind you that we really want to have an inclusive environment for everybody who's watching us. So while you are chatting, we really want you to familiarize yourself with our code of conduct. Thanks, Rasmus. That is listed in our main meetup page. And all of you, of course, as usual, are going to have an Azure Heroes Learner Badge that I'm going to talk about it later. So I'm going to hand it over to you, Rasmus, where you are going to tell us about our speaker and the topic.
Yeah, definitely. It's going to be really interesting today as well, like always. And the topic, as many of you most likely already know, is gonna revolve around creating interactive art and basic games using JavaScript and p5.js. So we're gonna learn how to create games today. That's awesome, right? So in this talk today, we're gonna learn about what is p5.js. A really good place to start. Also, the structure of a p5.js program. So when we're writing it, what is the structure? Also, some of the available functions. And also, we will all of us learn how to create our first sketch. So the first p5.js program, if you haven't done that already before. Then also a good old snake game creation in p5.js in the web editor. I look forward to learn how to do that and show my kids actually a snake game there, right? And
Yeah.
also important thing, how can everybody in the audience continue learning going forward? So learn about some resources. And no topic without a speaker. We have an awesome speaker here today as well. And our speaker today is Sabiha. And Sabiha is a Gold Microsoft Learn Student Ambassador and a recent computer science graduate from BITS Pilani in Dubai. She's super passionate about the technology for social good and diversity in STEM, she says. So Sabina is also her first solo trip to another country was freshman year of university for the Microsoft Office Specialist World Championship 2017 in Anaheim, California. So really interesting. Welcome to the Dev Show, Sabina. It's really great to have you here.
Thank you. Thank you for having me.
Yeah, great. Before you start, I have actually a question for you. And can you tell us that what is it actually the gold Microsoft Learn Ambassador, and how a person can be like you?
Sure. So the Microsoft Learn student ambassadors are basically like on-campus student leaders who lead technology communities, and they teach about different Microsoft technologies or even something that's not really Microsoft. So it's just your passion of technology that you share with others. And if you want to get started, you can just head to the student ambassadors website, and there's a link that you can apply it, and it's open throughout the year. So you can submit your application anytime.
That's great. I'm pretty sure many people out there might want to actually to get involved as well. And I would say that this is a really great way to actually start contributing back to the community as well. Great. So I would say that stage is yours, and I'm personally really interested to actually to watch your talk. So
yeah, take it away, Savia.
Thank you. Great. So we can get started now. So hi everyone. Today we're going to take a look at p5.js and how you can create interactive graphics and art in today's session. So before we even get started, let's take a look at what we'll be covering. So as previously mentioned, we're going to be covering what exactly is p5.js, some of the examples where p5.js was used, how you can get started, and at the end, we're going to use all of the knowledge that we've learned in order to create your very own Snake game. So what really is p5.js? Well, p5.js is a free and open source JavaScript library, and you can use this to create all sorts of interactive art and games with just a few lines of code. The main aim of p5.js was to make coding much more accessible for people who are just beginners or someone who's coming from a much more creative career like artists, and it provides them the sort of visual interface that they can see while they're learning to program. So before this, if you always wanted to get started with programming but found all the resources on the internet quite cryptic or you could not really understand them, p5.js and learning to program go really well together. So you can see the whole visual aspects as you're learning to program, like learning about loops, learning about variables. So this is a great place to start. So what do I mean by a visual sort of interface? Let's take a look at a few of the examples that were created using this library. So here we have the recreation of Conway's Game of Life, where you can see that this is very interactive and this was made entirely using the p5.js library. We have the recursive tree, which is also another thing that was made using this library. And finally, we also have these particles that were created using this. And this was all done with just a few lines of code. And these examples, as well as many more, are available on the p5.js website. So you could just explore and first see what people have created and get started on your own. There are two ways that you can actually get started. So the first way is you can head over to the p5.js website, download the complete edition, and open it on your code editor. The second option is going to the website and clicking on the online editor. So this is the easiest way you could get started. You don't even need to do any setup. Just go to the website and it will generate a sample sketch for you where you can begin working on right in your browser. And in today's session, we will be using this method so that you can quickly get up to date and start working on your programs. So once you have either the online editor open or you've downloaded the complete edition, you will come across with two main files in your structure. So one is the sketch.js and the other is the index.html. So sketch.js is where you'll be writing all the JavaScript code that is required to actually create the animation. So the animation you saw earlier where there were particles moving around, you'll actually be writing all of that inside of sketch.js. The index.html is just a place where you can view all of the code that you've written inside Sketch. So it just displays whatever you've created with code. Let's take a little bit more in-depth look at what sketch.js would actually have. So inside sketch.js, when you first create your program on the online editor, you will find this sort of two functions. So one is the setup function, and the second one is the draw function. So how does this work? Like what will run first? What will run second? So in a basic p5.js program, the life cycle looks something like this. So anything inside of the setup function will run first. So it's something that's going to run only once. It's going to be called at the beginning of the program. And anything inside a draw function would be called multiple times. So by default, it's called 60 times per second. So if any sort of animation that you want to make, maybe you want to make your snake move, that's something you would put inside the draw function because you want it to change constantly and not something that you create once and just let it be. Additionally, if we go in depth in the setup function, you're going to find something called as create canvas. This is synonymous to something where you're doing art on a canvas. With any sort of art or drawing, you would need a space where you're actually doing the drawing. And it's similar to what's on a p5.js program. So you're going to have a canvas where you're going to create all of your animations and all of your interactive art and games. That's why we always initialize this canvas at the beginning of the program inside setup. So there are a lot of different functions that p5.js offers. So we're going to now jump into the code editor and try out a few of these features which are provided by the p5.js library. So we're just going to head out into the code editor now. So if you'd like to follow along, you could also open up and just test out these different features and functionalities that we're showing you here. Great. So now you can see that this is the p5.js online editor. And if I just run whatever's currently generated for me, let's see what it gives us. So you can see that it just creates a canvas, which is gray. So that's what create canvas does here, right in the setup function, and does it only once. And I can see that the background is currently put as 220. So what really is this 220? If you know about the RGB system, so that's red, green, and blue, p5.js is going to use that as the way to set colors. So if you set just a single value 220, that's like setting 220 for each of these: red as 220, green as 220, and blue as 220. So it's basically generating a gray canvas for us. But I think this gray canvas doesn't look that great. Let's make it a bit more colorful. So I'm going to change this to something like a red color, a bright red color. So to do that, I am just going to replace this with 225, 0, and 0. So that's like setting all the red values and none of the green and blue. And I'm going to run that again. And I can see this bright red canvas, which looks pretty much better than what we had earlier. So great. Now we know how to change the colors, but what am I going to do with just a blank canvas? That's where p5.js has a bunch of different features for you. So you can add in shapes, you could add in points, you can add in lines, ellipses. There's so much more you could add. So let's begin by taking a look at how I can create my own circle on this canvas that I made. So to add a circle, there are two ways. One is that I could use the ellipse function, or there's another function called circle. But for today, let's try to use the ellipse function. So I'm going to type in ellipse. And the first, so this function takes in 4 parameters. So we're going to first define where do we want this circle to be displayed on the screen. So let's place it right at the center of our canvas. To do that, we're going to put in the x values of 200 and the y values of 200. So it is exactly at the center of our canvas because our canvas was out of 400 by 400. So it's right at the center. And now let me just give a size for my circle. So I'm going to give it 10 and 10. And let's see how that looks on the screen. OK, so we see a very tiny circle, but it doesn't look that great. So let's make it a little much more bigger, maybe. Let's make it 50 and 50. So now you can see that there's a circle right at the center of the screen because we placed it at 200 and 200, and we placed it and we made the size as 50 and 50. OK, so we have a nice white circle in the center of our screen, but I want to make this a bit more colorful. How could we make use of the red background? Maybe we could make the circle a black color so that it would kind of match with the background and look a bit better. So how do I do this? You might think I would have to change some background color using the background function. Well, there's another way to change the colors of shapes in p5.js, and that is by using the fill function. So I'm going to say fill. And again, inside this, I'm going to follow the same sort of RGB method of giving the color value. So since I'm looking for something that's black color, I'm going to just put in 0 because I don't want any color to be on the on the actual circle, so just a black color. So I'm going to give it 0, and I'm going to try run it. Okay, so now our circle looks black. So when you give something like 0, again, it's similar to defining it as 0 for red, 0 for green, and 0 for blue. So we can see now that we have something that looks a bit more better, like something you've created, more like art. So this is a quick way you could just get started with the editor online. And let's jump back to see what other features are there on p5.js and just take a look at what the different other options are. So we're not going to create everything, but we're just going to take a look at what other options are available back in our presentation. So let's head back there. And so we have the p5.js colors, which we just took a look at. So these are the different background colors. You can define not just black, not just red. You could think of any color that you want and add it as your background color. We also took a look at a few of the shapes, like the ellipse and even the circle. So a circle would be an ellipse which has the same values for the width and height. And we have the rectangle and the line and point. So these are a few other shapes that you can quickly create on p5.js. And the way that you would create them is very similar to the ellipse that you just created. So it would be a rectangle. You give them the x and y coordinate. That is, where do you want it on the canvas? Then you have a width and a height. So you can fill in these values with just one line of code. You have a rectangle of your own. We also have a line. So you could give it a point where you want it to start. So like a xy coordinate of the start point of the line and an end point of the line. So it would create a line for you, and that would span across the distance that you've given. And we're going to be coming back to this a little later today, because we're going to be creating a snake, which is essentially a line which in p5.js. So the other aspect we took a look at was colors. So we have the fill color, which we use to fill in the circle with our black color. And the other options, you see, there's something called stroke and stroke weight. So where do you use this? Stroke weights and strokes are basically used when you're working with lines. So if you had to change the color of a line, you would use stroke and then put in the color value inside that. And if you had to increase the thickness of the line, you would use stroke weight and give it a value. So these are also, again, we're going to come back to them when we're making the actual snake, because we want it to look quite nice and something that, you know, looks like your traditional snake game. So you could show it to your friends. So without further ado, let's actually get started building the snake game. So as you can see in the screenshot, the snake game would be a snake. You would have a fruit or like a ball that you're trying to catch, and you have the actual score of your game. So this would be something that would be available in any kind of snake game that you pick up. So something on the browser or even one of your traditional laptop snake games. So again, the components would be, for a snake, you would want to move the snake, and you would actually want to get the fruit that's on the screen. So how do you do that? And you always want to grow your snake, because if you pick up a fruit, you don't want the snake to just be of the same size always. And there's no real point of the whole game. So we're going to learn how to do this whole motion, how to do the whole growth thing, and also how do we work with like placing different objects on the screen and having the snake actually get them. So the first thing we're going to get started with in the editor is working or creating our own snake on the actual canvas. So for the snake, we're going to need a starting point. So we want to place it somewhere maybe in the middle of the canvas so that we could see it when the actual program begins to run. We also want to track where the snake is moving. And in a sort of canvas, the way you track the motion would be the changing x and y coordinates of where the snake has been. And the next thing you want is to actually respond to the key press. It's not fun if your snake is not really moving when you're trying to move it. So we obviously need to figure out how to actually move it. And that's using the key press functions using p5.js. So let's head to the editor and try to actually make our first snake and go ahead and run it and see how it looks. So we're going to now head back to the editor, which was where we were working with. And so we have an empty sketch again here. And we're going to now start by just thinking about what we actually need on the program. So now that we have a canvas, which was, if you run it again, it's the same canvas that we started with for the other program. Let's start by giving it a traditional sort of background. So I'm going to make the background black. So if you remember, we just changed the color here to 0, which is black. And when I run it, I get a nice black canvas to work on. The next thing is I want a snake. So the snake is closest to a line, and we know how to create a line on the p5.js library. So let's get started. Let's just create a simple line, like a line, and give it the coordinate of 50 and 100. So this would place it at the x coordinate of 50 and the y coordinate of 100, and 60 and 100. So this is the second xy coordinate. And now when you run it, you don't really see anything. And that's because p5.js takes the color of the previous declaration. So it's taking even the line to be of a black color. And we don't really want that because we want snake to be visible and we try to collect fruits using it. So how do we change this? If you remember, we use stroke and stroke weights to kind of move around, play around with the actual properties of a line. So to do that, we're now going to add a different property called stroke and add in a color. So we want the snake to look white, like a traditional snake game. And let's try to run it again. Okay, so now we're seeing like a very thin line that looks like a snake, but it's too small and it doesn't look that great, right? So we want it to look quite obvious and we want it to be visible for everyone. So we're going to increase the thickness and make it look a bit more standing out. So we're going to we're going to write stroke weight and give it a value of 4. And you can see it's much more thicker than how it was. So maybe we could increase this a little bit more. Okay, so now it looks more like a nice segment of a snake. And we want this to increase as we go. So we're going to work on that. But now that you have the snake, the next thing you might be thinking is, let me try moving it with my up and down arrows. So when you try moving it with your up and down arrows, it's not going to move because we haven't really given anything or any sort of functions to actually make it move. So to make it more interactive, we could start adding some sort of key presses. But before we even do that, let's just take a look at the code that we've written. So we've written that we want a line that goes from 50 to 60 on the x-axis. And that's a static line. And it never really changes. So you know that when you're actually working with a snake game, you always remember that a snake always moves on the canvas. It's constantly changing the location. It's trying to capture the next fruit. But with the program we just wrote, there's nothing really changing all the time. And that's not great because we want the snake to move. So how do we change this? So instead of hard coding it like 50 and 60 here, let's get rid of this and write a better way to actually create this sort of program. So instead of hard coding it, let's create a few variables. So we're going to start off by adding a variable for the position where we want the actual snake to start. So let's say we want it to start at the 50 x coordinates. So we're going to say x position is 50. And we want the y position of the snake to be somewhere around 100. So this is going to use 50 and 100 as where the snake would first start when you run the program. The next thing is that we want the snake to move by default in the right direction, because if someone's not moving the keyboard, we still want the program to run. So we want the snake to still move a little bit. So we're going to set the default direction of the snake motion as right. And let's also add in a extra thing, which is for the segments. So the way that p5.js works is you could either create a single line that's always static, or you could create something that's constantly changing, like something that's redrawing that line every time, which is making it look like it's moving. So usually when you have this sort of animation, it's kind of redrawing these little segments again and again to make it look like it's actually animating. And if you remember how animations used to be done in the previous years, like when it was super olden days, it used to be like an animator redrawing again and again these segments, and it used to move. It used to look like it's moving. So similar to a flip book. So that's what we're actually trying to accomplish here. So with the actual snake, we're going to give it a few segments like this, and we're going to say it's a segment. It has a segments as 10. So it's going to basically use these segments, and it's going to redraw this every time it's moving. So the snake is moving, it's going to move the segment a little further and then a little further, and that's going to make it look like it's actually in motion. So we have the segments, great. Next, we know that the snake is moving on the screen, so we know that the X and Y coordinates are also changing. So we need a way to track this. We can do this with a simple array. So we're going to also have a place to track that. So we're going to have the X coordinates, and then we're going to have the Y coordinates, and we're going to keep track of them in the array. And so we have pretty much most of the things that we need to initialize where the snake starts and the X and Y coordinates of where it's going to move. So once we have this, we need to now fill these X and Y coordinates. So how do you actually tell it that you need to move it from the left side of the screen to the right side of the screen? When every time a snake is moving just a bit, we know that the X, Y value is changing. So we need somehow to tell our program that this X value is changing, the Y value is changing. So for that, we are going to write a small loop, which is right here. So I'm just going to paste this in right here, and we take a look at what it actually does. So we have a loop that's iterating through the number of segments, and what it's doing is it's pushing a value into the X coordinate array and a value into the Y coordinate array. And this value is changing all the time. So we are actually, maybe we can take a look at what it's giving you. So it would give you a better understanding. So let's just console.log and see what the program's giving you for this particular segment. So I think we renamed this. Let's just call that number segment. And oh, all right. So we kind of missed out a few things here, but let's add what we're missing. So let's say that at each point we wanted to move a little bit more. So we're going to set a extra variable called diff. So we wanted to move by like 10 or by 15. So right now we just set it to 10. So when we do that and we run it, and we see the results right here. So let's just stop this as well. And let's take a look at what this p5.js program is returning. So we can see that the values of X are changing constantly. So p5.js is putting these newly generated values of X coordinates into the X coordinate array, so that later when it's animating, it can use these values to change where the line actually is. So this is a quick like overview of what's happening inside this loop, and you're going to be able to understand this a little bit better when we actually have the line on the screen. So now that we have this loop, let's head to the next part of the program, which is actually creating the line. So right now, if you take a look, we actually added all of these items inside of the draw function. But if you think about it, do you really want the snake starting position to always run like 60 times or like 70 times or single second? Or do you want it only to first be generated once? Like, do you want a canvas to be created at the first time and then later on you could animate it? So if you think about it, you just want to set the initial positions and the initial coordinates at the beginning. So you don't want to really change that all the time. So instead of putting all of this inside a draw function, we are going to move this into the setup function. So if you remember, setup function is only going to run once when you first run the program. So we're going to set up how the snake looks, what the coordinates are for it initially inside the setup function. Now, if you go back to the draw function, it's pretty empty. And we're going to use the information that we declared earlier to create a line. So we're going to have another loop right here where we are going to loop over the segments. And now the line is going to use these coordinates that we just pushed into the array and use that to create the line. So initially, we were passing in something like 50, 100. So we were giving them very rigid values. And right now, what it's going to do is it's going to use the coordinates that it created right here, which you can see on the console, and use that to actually generate the line on screen. And let's see what this is going to give us. So if we just run this out, you can see that there is a snake now again, similar to what we had earlier, but now these values of x coordinate and y coordinate can later change in the program. So it's going to change the motion of how the actual snake is going to move. So we have this, but next thing we need is how do you actually make it respond to your key presses? And how do you update the snake such that if I just run the program, it should still move? So let's create an extra function right here called update snake coordinates. And let's define this function later in the program. So we're going to create a function right here and define it inside these brackets. And what we're going to do here is that if I just run my program and I don't do anything, I still want the x coordinate to increase and it should move to the next position on the screen. And to do that, we're going to have a small loop right here again. And what this loop does is that the x coordinate, which is currently set, is now going to get the value of the next coordinate that's in the array. So when we initially ran the console.log, you saw how the value was changing from 50, 60, 70. So it's basically going to update the current coordinate with the value that is the next coordinate, so like 60, and it's going to go to 70. So that's how the actual animation is going to happen. And if I run this again and also modify the variable name, you can see that there is a snake moving. And it stops right there because we haven't set the condition for what to do with the last segment of this particular snake. But you can see that it's moving, and it looks similar to how you would if you would animate a snake. So now that you have these segments, the next thing you want to do is actually set the condition so that it doesn't stop at this particular point. You want it to continue moving like a snake. So to do that, we are first going to set a key press so that we can also control the snake while we set the other conditions. So to set the actual key press, we are going to have a function called key pressed, and we'll add this outside the other ones. So we're going to have a key press function. And in p5.js, there is an easy way to refer to the keys using key code. So if we just search, or if you just put in right here, key code equals to left arrow, this is an easy way to refer to the left arrow that's on your keyboard. So this you could use key code equals to, and left arrow. So this is a way you could refer to it. And what do we want to do with this? So we want this not only for the left arrow, we want this for all of the different arrows on your keyboard. So like your up arrow, the right arrow, and the down as well. So we would need conditions for that. So when someone presses the left arrow, do you remember we set this particular variable that said let direction equals to right? So we want to change that because we want the direction to now be left. So we're going to make use of this really handy variable that we added initially. And we're also going to just say here that the direction would now be left. And this would have to be repeated for the other keys, which is right arrow. So when it is right, we would say the direction is right. When it is now a down arrow, we would now want the direction to be downwards. And when the key code that we press is up, we want the direction to now be up. So with just these few lines of code, we are able to tell p5.js that we're pressing the left arrow, and when you press it, set the direction to left. And these values that we're setting to direction, we're going to make use of that in our draw function and in our update snake coordinates in order to actually do something when the direction is left and when the direction is right. So now that we have that, let's go back to our snake coordinates function that we had, and let's create something that would check what the direction is and do something with it. So let's have a switch statement right here. And inside that, we're going to add some cases. So what should we do if the case is right? So what should we do when the value that I get from the direction is right? So when it is right, we're obviously moving the snake forward. And we right now, if we run it, we see that the snake actually stops. So we need to do something with that last segment of the snake in order to not make it to stop. So for that, we have a additional few lines of code that we're going to add, and then we're going to look over what it actually does. So right here, what we're doing is the x-coordinate is x-coordinate of the last bit of the snake, which is the num segment -1, is now going to be set to the one that was before it. So the last segment is now going to be set to the coordinate that is increased by a predefined value like diff. And this is going to differ on the basis of, is it going right? Is it going left? Is it going up? Is it going down? So we're going to use this sort of weight in order to make it not stop at that particular section. So we named it num segment. That's why we're just getting rid of that extra s from there. So yeah, so basically instead of the last segment just ending, we're going to now set it to the segment that was before the ending segment and add a diff value, which we had initially initialized. So it's going to move it by just that little bit of amount. And the y coordinate is now equal to the one that was like just before the last segment. So that's what we are doing with the -2 right here. So this was the last segment, and then this is one before it. And this is how we would be doing it for the right. And how do we do it for the rest of them, which is up, left, and down? So we're going to do a very similar sort of approach. So for the up, we are going to have a similar sort of approach where we add in these values. So let's take a look at each of them again. So we have the right already, so we are going to get rid of that. And we have the up, left, and the down conditions. So with each of these, we are going to decide. So with the up one, you would have to change the y coordinate, and the x coordinate is going to be pretty much the same. So that's why we have the x coordinate to just get the value of the previous, the one before the previous, the ending, and the y coordinate would get the value of the one that is just before the ending and then minus diff. So this is a little bit of, I guess, it's a bit tricky to understand, but the essential part of this code is that you're trying to make sure that whenever like you reach the end segment, what's the next thing you should do? So it is then setting the x coordinate as the one that was before the last one. So it's just a way to kind of set a condition when it reaches the end. So what do you do next? So let's just make sure that the variable names are consistent throughout, and let's just try to run it. So now we see that the snake is in motion, and it's no longer terminating at that particular segment that it was initially. So this code that we added, it's making sure that whenever it reaches the last segment, there's still something that it can do. And now, since we also added the key presses, let's try to see if we can move it. So on pressing the keys on my keyboard, I can now move the snake along, and I can see that it's also moving. And that's great and all. And we can now move the snake, but it looks like it's moving pretty fast. So we would still like the user to get a bit of information on what the game actually is before they start playing it. And right now, the snake is moving really fast. So how do we reduce the speed of the snake? You could do that by simply adding a extra value right here in the setup function. We're going to set the overall frame rate to be 15. And what this does is that it would make the snake a little slower, because the frame rate would be the number of times that the frame would be rendering in a particular second. So we have 15 right here, and it's going to make sure that it would, by default it's 60. So when we made it 15, it would render it much less. It would also make the animation look less smooth. So I mean, if that's something you're okay with, you could add it onto your code. Or if you want it to look like the snake is moving really fast and really smooth, you could keep it at the default value. So we have a snake right now, and it looks like a traditional snake game. But what's the purpose of the snake game if we don't really have any fruits or any scores or anything that you would like to actually, continue playing the game for? So to actually add the fruit, so we are going to go back to our place where we added the draw, the update coordinates inside the draw function. So now every time that the draw function is running, the update coordinates is being called. But we also want something for the fruits. So we're also going to have another function that says check for fruit. And what this is going to do is basically check for a fruit that we're going to create in the program. So let's head back at the top, and let's create a few variables to give the position of the fruit. So let's start off by adding the fruit starting point as 20 in the x-axis, and the y-axis, we can give it a value of 20 as well. So now what this is going to do is it's going to use this particular variable definitions as the starting point of the fruit. But for that, we need to actually create the fruit. And to create the fruit, one of the p5.js shapes that we could possibly use is the point shape. So we're going to use that in today's lesson, and we are going to create a point. And to do that, we are going to go back to our function right here and just add in an extra thing for the point. So when we created the check fruit function, we are also going to create the function right here so that we can actually say what it's going to do. And this function is going to create a point at this particular location. So we're going to create a point at the x location and the y location using the value that we just defined here with the variables. And what this is going to do is just create a fruit at that location. So if we run it, we can see that there is a fruit now here, right here. But it doesn't really do anything. So if I try to now go and collect this, it won't do anything. So there are no score systems. The fruit is not collectible. So how do we actually set the whole collection system? So we need something that we can use to check if the snake is really overlapping with where the fruit is, and how do we, or what do we do when it overlaps. So to do that, we're going to just use a simple if statement to check how the overlap happens. So we're going to add in a section right here. So what this does is it's basically checking if the current x coordinate is equal to the x fruit, which is where the fruit is, and is the y coordinate equal to the where the fruit is, then you know that the snake has gone over the fruit and it has been collected. So once you have this sort of if statement, what do we really want to do? So we want to increase the score, and we also want the snake to increase in length. So for the snake to increase in length, we remember that there was a number of segments that we declared earlier. So we're going to just increment that so that now the snake would have 11 segments. So we're going to give a num segment. So let's just copy that from there. We're going to increment this because we want the snake to grow in length. And also, we want a score system. So right now, we don't really have a score system at all. So let's create an extra variable at the top. And let's say by default, it is 0. So you don't have any score when you start out. And we want the score to increase when the user goes over a particular fruit. So we're going to also set the score to increase right here. And once that's done, we now know that the score is increasing. And let's actually just put it inside, put a console.log so we could see when or how the score is increasing. So let's have the score that's displayed to the user. And let's now try just running it and moving or trying to catch that fruit which is on screen. So now we're moving our snake, and okay, so we can see that there is a little bit of, so we can see that the score has increased, so it's now 1, and there is a little bit of an error that we can try to fix it. So in order to fix this, we just need to make sure that we add in an extra condition that shifts the x coordinate and y coordinate back to the starting point. So you don't want the snake to end when it touches the particular fruit. So we're adding this x core and y core dot unshift in order to move it back. So let's try now again. If we go over, try to catch that, and now we caught that fruit, and it is now showing that the score is 1, but the fruit is still there. So in order to actually move the fruit along or even get rid of the fruit when the snake touches it, we would need to add many more conditions and have some sort of like a randomized function where the fruit kind of varies across the screen. But in order to create a very basic snake game, this was what we did. So if you just go over it again, so we created a few coordinates to denote where the snake would be starting. We created a array which is keeping track of the coordinates where the x and y, where basically where the snake is going on the canvas. We also created a fruit which we gave it a location of 2020. We set up the coordinates in the coordinate array by basically populating it with a few values so that we can use that later in order to animate it. And inside the actual draw function is where we're calling a bunch of different functions, if you remember. So we had an update snake coordinates, we had a check for fruit. So if we go to the snake coordinates, we had a way to check the direction, which direction did the user press on the keyboard, and what should I do if that particular direction came in. And we also have a key press function that we created, which was the one that's actually listening for and telling you which direction the user clicked. And you also have the check for fruit, where the location of the fruit is being compared with the snake's location. So is the snake going over the fruit? And if so, have we incremented the score and have we incremented the segments on the snake? And this is just a very simple way that you could create a snake. And some aspects might be a bit confusing, like why do we have so many coordinates, or why are we trying to like change the coordinates every time? And this is because in p5.js, you are kind of essentially resketching that particular line a little bit forward and a little bit forward. So having this sort of coordinates, the p5.js program is essentially sketching the line again and again a little bit further to make it look like it's in motion. And that's what we're basically trying to accomplish through this simple sort of code snippet. And additional, like if you want to add more features onto the snippet, there is a great example on the p5.js examples website. So you could just even run it directly from the example website and see how the snake is working. And you can even play the game right there. So that's one way that you could create a simple snake game. And let's actually head back and see how you could kind of, or what can you do after you learn about creating simple games? What's the next step? Like, where do I go to learn more about p5.js? And so for that, we're just going to jump back into our presentation and see what are the different resources that are available. So we created the snake, we created some fruits, and you could update the position later on by just playing around with the code. And so from here, you can go on to the p5.js Learn, where you can get a very detailed documentation of what each functionality in p5.js is. So when we talked about creating rectangles, what does each, like how can I create different rectangles? What does each of the attributes mean? You can find all of that on the p5.js Learn website. And there's also the Coding Train YouTube channel, which is a great place to just learn about how to create this sort of interactive art and graphics. And you can get started by just watching a few videos. And if you feel like you need a little bit of a refresher on JavaScript, or you want to improve your JavaScript skills, there are great MS Learn paths which use both Azure and JavaScript on Microsoft Learn. And that's some place you could kind of go to if you want to do a bit more reading on that. And apart from that, you could always reach out to me on Twitter, or you could send an email to my student ambassadors account. And thank you for tuning in. And if you have any questions, I think it would be great to hear them.
Thanks for a great presentation and demo. It's amazing that you can actually create a basic game in such a short time. So really awesome. We had one question in the audience, probably a quick one. Can you use the hex values for colors in p5.js?
So you could. The better way is to use the RGB values. Like instead of giving an RGB, you could just give a overall value, like just like how I gave it to 0 or 2 to 0. That is the better way to do it. So yes, so that's the way you should probably do it as well.
Yeah.
Okay, that's really great. Sherry, do you have any questions before we move on to the feedback?
No, we have only 3 minutes, so
yeah.
we have to be pretty quick. And thank you, Sabiha, for a great talk. I really loved it. And so feedback.
Yeah, we need everybody's feedback, both for this session and also from the program, the show in as a whole. And I heard in the beginning that Sherry was promising some gifts if you give feedback. So remember, if you give feedback and want to be in on getting some swags, you need to put in your email address in how we can contact you field, so we can get back to you, because otherwise it's anonymous. So feedback form here. Also give us feedback in the chat, in Twitter, anywhere. We would like to hear how we're doing and how we can improve your program.
Yes, and I already shared in the chat the link to your Azure Heroes Learner badge. You can also, of course, scan the QR code to get your Azure Heroes Learner badge. And if you want to have more information about our program, you can go to ika.ms/azure.heroes and nominate yourself or your community friend for the other awards that we have there. And remember, you can actually add yourself to the map as well. And you can also find the other Azure heroes around you. So what are the...
Yeah, what's coming up? So we have the Cloud Secrets to go, where Sven is going to talk about understanding Azure app configurations. And then next week on the Dev Show, we're going to have GitHub in Action by Morten Christiansen. And I forgot, the Monday show is Machine Learning Sustainable by Sarah Bagman. And also one speaker coming back to the Dev Show. Actually, the first speaker we had on the Dev Show, Chris Noring, he's going to talk about a Blazor. And that was also an ask that the audience put into the feedback form. So here we are listening and giving you the sessions that you want to hear. And then it's good to have Chris back as well. Check all the shows. We have the program lined up all the way to the end of the year. So go to the Dev Show meetup page and see everything.
And Hacktoberfest is going on. If you need inspiration, a project to listen to, go to contributing.today. And for those of you who are watching also on Twitch, the contributing.today is starting right now. So see you all next week. And thanks for joining us. Bye-bye.
Thanks, everybody, and thanks.